Today, I want to give you a hands-on introduction to how blockchain works as a developer. And it doesn't matter if you're an experienced developer or if you're just learning to code. I'm going to teach you blockchain from square one. We're going to build a blockchain social network where you get paid to post. You can earn cryptocurrency rewards for creating great content. I'll guide you step by step to build the full application from start to finish. We'll set up a blockchain, we'll develop smart contracts for the social network, and we'll create a client-side website so that anyone can connect to the application and post to the social network. And you might be thinking, I don't even know what a blockchain is or how it works. That's okay. I'm going to clarify all these kinds of questions at the beginning before we start coding. So if you're new around here, hey, I'm Gregory from Dapp University. On this channel, I teach you how to become a blockchain developer. So if that's something that you're interested in, click the like button down below and click subscribe. That really helps these videos get found so that more people can learn to become blockchain developers. All right, so before we start building the application, let's answer a few questions, like what is a blockchain and how does it work? So if you're familiar with these things already, feel free to skip ahead. But if not, let's get started. What is a blockchain? I'll use an analogy to explain how a blockchain works. Let's look at a bank. Suppose that Alice wants to send money to Bob with a wire transfer. All of her money is stored inside a bank account, which has two primary purposes. It keeps track of how much money she has, and it provides an online portal that allows her to perform the wire transfer to Bob. Behind the scenes, the bank has two primary technical features that make this possible. A database. The bank maintains a database ledger of all Alice's transactions to determine her account balance and transaction history. And a network. The bank uses a network to process wire transfers so that funds can be sent from her account to Bob's. Blockchain presents an alternative to this model by eliminating the need for a bank altogether. Instead of sending money to Bob via wire transfer, she can send him cryptocurrency directly with a blockchain. Much like a bank, the blockchain gives her a place to safely store her funds and send money to Bob. It replaces the two primary technical features of a bank. A database. It also keeps track of how much money Alice has. And a network. Alice can connect to a blockchain in order to send money. When she does, the blockchain processes her transaction and moves the funds from her account to Bob's. Because it serves both of these roles, you can think of a blockchain as both a network and a database at the same time. Let's examine both of these concepts further. A blockchain is a peer-to-peer network, meaning it's a system of nodes or computers that all talk to one another. It is responsible for processing transactions so that Alice can send money to Bob. She simply needs to connect to a node on the network in order to initiate her transaction, and the blockchain handles the rest behind the scenes, which we'll see more of in the next section. Now let's examine how blockchain functions like a database. Each node on the network maintains a copy of all the data on the blockchain. For example, they all know how much money Alice has in her account. Instead of a bank storing all this data inside a central database, the blockchain stores it redundantly on each node in the network. This makes it virtually impossible to tamper with the data. For example, Alice cannot manipulate her account balance because all of the other nodes know exactly how much money she really has. And really quickly, it's important to note that blockchain and cryptocurrency are not the same thing. Bitcoin is a cryptocurrency, but blockchain is the underlying technology behind Bitcoin. Blockchains can be used for other purposes besides cryptocurrency, which I'll demonstrate throughout this tutorial. Now, how does a blockchain work? Let's continue on with the example from the previous section. Suppose Alice wants to send some Bitcoin to Bob. In order to do this, Alice and Bob each need an account on the Bitcoin blockchain. Their accounts are much like their usernames. Alice must know Bob's username or account address in order to send cryptocurrency to him. Next, Alice needs a Bitcoin wallet in order to send the transaction. In this scenario, her wallet reflects that she owns 10 Bitcoin. This is called her account balance. Being very generous, she decides to send 1 Bitcoin to Bob through this 3-step process. First, she enters Bob's account address as the recipient. Then she specifies that she wants to send 1 Bitcoin to Bob. Finally, she signs the transaction in order to make it official. In this last step, Alice signs the transaction with her private key. If her account address is like her username, then her private key is a lot like her password. It's sensitive data stored inside her Bitcoin wallet, which she won't share with anyone else. Her private key allows her to create digital signatures that authorize her transactions on the blockchain, like sending 1 Bitcoin to Bob. At this point, Alice has done everything she needs in order to complete the transaction. The rest is processed behind the scenes on the Bitcoin blockchain. Let's see how that works. After Alice's transaction has been signed, it is sent to the Bitcoin network. A select group of nodes called miners process her transaction and record it to the blockchain. These Bitcoin miners must solve a mathematical puzzle called a proof of work problem in order to record Alice's transaction. Each miner competes with one another to solve a cryptographic puzzle where they must correctly guess a random encrypted number called a nonce. The miner that guesses this number first submits their answer or proof of work, and this authorizes them to record the transaction to the blockchain and receive a Bitcoin reward for winning the mining competition. Whenever they record it, they create a new transaction record on the blockchain. Groupings of these transactions are called blocks, which get chained together to make up the blockchain. And during the mining process, the network reaches consensus, meaning that each node verifies that they have the same valid data as everyone else. This is called the consensus algorithm. Effectively, each node says, yes, I have a valid copy of Alice's transaction. If they all agree, the transaction is complete, and the cryptocurrency gets transferred from Alice's account to Bob's. When Bob checks his wallet, he'll see that he now has 1 Bitcoin. So why do we need blockchain? Well, let's continue on with our banking example. Here are some reasons Alice might choose to use a blockchain to store and send money. One reason is transaction speed. Suppose Alice and Bob live in different countries. An international wire transfer could take days to complete. Instead, Alice can send Bob Bitcoin in a matter of minutes. Also, transaction fees. Let's say Bob is a merchant and Alice wants to pay him money for a very expensive service, maybe $10,000. If Alice paid Bob with a credit card, Bob would incur a transaction fee around 2% or $200. But because Bob is Alice's friend, she pays him with Bitcoin to save him money. Now Bob incurs no transaction fees and Alice only pays a few extra dollars to send money to Bob. There's no third parties. They don't need to sign any documents or wait for clearance in order to send money. Another reason is transparency. Instead of a bank storing all of her data, she can verify her account balance and transaction history on a secure network. Also, security. Traditional databases and IT systems can be very vulnerable to attack. In blockchain, it's virtually impossible to hack the public ledger in order to change Alice's account balance or transaction history. And finally, anti-fraud. Because blockchain transactions are publicly verifiable, they enable companies to build anti-fraud solutions that make it very hard to fake transactions or embezzle funds. Now let's talk about how to become a blockchain developer. Up until now, we've discussed how to send money with the blockchain. Now I want to focus on how to use blockchain to actually build applications. Unfortunately, Bitcoin is quite limited in this area. So we'll look at a different blockchain called Ethereum instead. In addition to sending cryptocurrency, Ethereum allows developers to create decentralized applications or dApps that run on the blockchain. Ethereum achieves this with smart contracts, which are programs that run on the blockchain. Let's see how these apps work. First, let's look at how a web application works, and then we'll compare and contrast the two. Normally, when you use a web application, you use a web browser to load a web page, and that talks to a central web server over a network. All the code for this app lives inside the central server, and all the data is housed inside a central database. Anytime you transact with this application, you must interact directly with the central server. This presents a few problems. The application creators could change the code on the server or the data in the database at any time because they have full control. We can eliminate these problems by using the blockchain instead. Here's how it works. We can use our browser to load a web page, and that talks directly to the blockchain instead of a back-end server and database. We can store all of the application code and data on a blockchain instead of this central server. This is a fully transparent and trustworthy way of knowing that the application code and data won't change. But why is that? All of the backend code for the application will be made up of smart contracts. These are the building blocks of blockchain applications. All of the code for the smart contracts is immutable or unchangeable. Once the code is put on the blockchain, no one can update it or tamper with it, and we know that it will work the same way every single time. Smart contracts are written in a programming language called Solidity, which looks a lot like JavaScript. They're in charge of reading and writing data to and from the blockchain and executing any business logic that we program. They work a lot like a microservice on the web. Also, they're called smart contracts because they represent an unchangeable digital covenant or agreement. All of the data for the application will be stored as transaction records inside of blocks on the blockchain. As we saw earlier, each node on the network maintains a copy of all this data to ensure that it is secure and unchanged. So that's how a blockchain application works from a high level. In the next section, we'll get a closer look by building one together step by step. Here's the blockchain app, or Dapp, that we're going to build. This is a blockchain social network powered by smart contracts where you get paid to post. Other users can tip your status updates with cryptocurrency so that you're rewarded for creating great content. We'll even curate the newsfeed so that the most tipped posts appear at the top instead of relying upon an algorithm that nobody understands. This is a much better newsfeed because our social network is censorship resistant, which means that no third parties can tell us what we can and can't post, and they also can't limit what we can see inside of our newsfeed. We'll also create a slick, mobile-friendly user interface where everyone gets a fancy icon automatically for their account. Before you get started, you need to make sure you have Node.js already installed on your computer. You can see if you have Node installed by going to your terminal and typing node-v. You can install Node with a package manager like Homebrew, or you can download it directly from the Node.js website. The first item in the Blockchain Developer Toolkit is a personal blockchain. We're going to use Ganache as our personal blockchain for this tutorial. You can head over to truffleframework.com/Ganache to download it. You can click this download link, and whenever you've downloaded it, make sure you install it, and when you open it, you've got a local blockchain running. So what is Ganache? What is a personal blockchain? Well, a personal blockchain is like a real blockchain network, that's connected to the public where anyone can connect to it, but it runs on a computer. It's, a closed network. And Ganache basically, is a process that runs on a computer that spins up this blockchain and runs on a server. So we can use this to develop smart contracts, we can run tests against it, we can run scripts against the network, develop applications that actually talk to this blockchain, and it's really helpful and it's an invaluable tool in the Blockchain Developer Toolkit. So if you open Ganache, you'll see 10 accounts listed here. These are the addresses to each account on the side, and you'll see these balances. You'll see 100 Ether. This is the Ethereum cryptocurrency that each account has and is required to pay gas fees in the network and stuff like that. All right, so that's an overview of the Ganache personal blockchain network, and we're going to leave Ganache here set up in our project because we're going to need it running in order to develop our project. The next dependency is the Truffle framework. We're going to use the Truffle framework to develop Ethereum smart contracts with the Solidity programming language. You can install Truffle by going to your terminal and typing npm install-g truffle at 5.0.5. And it's important that you use that exact version in order to follow along with this tutorial. So Truffle is a suite of tools that allows us to, develop smart contracts, write tests against smart contracts, deploy smart contracts to the blockchain. It gives us development console, and it also allows us to develop client-side applications inside of our project. So it does a lot, and I'm going to show off all those features in this tutorial. The next dependency is the MetaMask extension for Google Chrome. Remember that the Ethereum blockchain is a network, and we need a special browser extension in order to connect to that network. And that's where MetaMask comes into play. MetaMask will allow us to connect to the blockchain with our personal account and actually interact with the smart contract that we'll develop in this tutorial. You can install MetaMask by going to the Google Chrome Web Store and searching for MetaMask and clicking install. And once you've installed it, just make sure that you enable it inside of your Chrome extensions like this. You can also see the little fox icon in your extensions tab. Now that you have all your dependencies installed, let's go ahead and start building the project. Find wherever you downloaded the Ganache personal blockchain and open it. Once you see a screen like this, click Quick Start. And after that's finished loading, you'll have a blockchain running. This will be the development blockchain that we'll use to create our smart contracts. This blockchain comes with 10 accounts, and each of these accounts comes pre-mined with 100 fake Ether. Each of these accounts is going to represent all the users on our network. In this case, anyone who can post on the social network and give tips. The account addresses are going to be like the username on the blockchain, and the private keys are going to be like their password. And also, don't get too excited because this Ether isn't actually worth anything on the real Ethereum network because all of the Ether on this blockchain just stays inside of Ganache. The next thing we want to do is create the files for the project. There are a few different ways to do this. You could do it natively with the Truffle suite by creating a new Truffle project like this. You could say Truffle init, and this would create a new Truffle project for you. But instead of doing that, I'm going to use a template that I created to help us get started fast. All right, you can find that on my GitHub, and I'll put a link down in the description below. This is just github.com/dappuniversity/starter kit. So we can use this by copying this URL, going back to the terminal, and typing git clone, and then paste in the URL. All right, hit space, and we'll create the project like this. We'll say social-network. And this is going to create our project for us. Now we can enter into that newly created directory like this. We'll say cd social network. All right. I'll just check out the files that are in here. I'll say ls-l. That's how you list all the files inside of this directory. Now I'll open it in my text editor like this. I'm using Sublime Text, and I've configured a shortcut on my system to where I can open Sublime Text like this. I'll say subl dot. All right, that just opens Sublime Text in the current directory. All right, there we go. So here you can see on the side there are some files already created. The first file I'll look at is this truffle-config file. This is the file we use to configure the Truffle project, like tell it the blockchain we want to connect to. This is how we tell our Truffle project that we want to connect to the Ganache instance that we just set up, right? And tell it that Ganache is running on port 7545 on localhost. You can see that right here. All right. And while I'm looking at this file, I want to mention something. All right. This project works slightly differently from a standard Truffle project. I've actually customized this to put the smart contracts in a specific folder. You can see I have a source folder here. That's because I want to put my smart contracts and their ABIs inside of a directory that can be exposed to the client-side application, which we're also going to build inside this project. And don't worry if you don't understand that just yet. I'll explain that when we get there. But just in case you've worked on other Truffle projects before, just understand that I'm going to be doing things slightly differently, but you shouldn't have any trouble following along with me step by step in this tutorial. So inside of this source directory, we have a place for the smart contracts. We can see a existing smart contract inside of here. All right, this is the migrations smart contract that comes with the standard Truffle project. This simply is a smart contract that allows you to put new ones on the blockchain. So we'll create our new social network smart contract here momentarily. We can also see some files for the front end, which we're going to build in React.js. So you can see a main app.js component. We'll customize this here, and we'll create more code inside of here to actually interact with the blockchain and build out the client-side application. So let's go ahead and start the development server just to make sure that the project was installed correctly. And actually, before we do that, we need to install our node modules. You can see we have a package.json file here that includes all of the dependencies that we need in order to build this project, so that you don't have to create them one by one. All right, this is one of the reasons I've used the starter kit, is to save a lot of time. So let's go ahead and install our dependencies. I'll just say npm install. All right, that worked. And I'll make a mention while I'm here. If you see some extra output here, you might just have some warnings, right? As long as you see this success message down here, it's okay. Your dependencies installed correctly. It's certainly not ideal to have a lot of warnings, but we can try to fix those as we go on. Now that the dependencies are installed, let's go ahead and start the development server. I'm going to open a new tab here so that I can have a server running and then a tab to work in. And so I'm going to run the server like this. I'll say npm run start. All right, so it looks like it already opened up a new tab for me in my web browser. I'll go ahead and pull that onto my screen here. And there we go. There's the starter kit that comes with our project. All right, so this starter kit gave us a lot of stuff for free. We have a front-end framework so that we don't have to write a lot of CSS. We have some UI that we can just simply customize for our purposes in this project, right? We have a nav bar. I've got some nice-looking fonts, some styles for our text and links. Even got a logo here. And also, we have the React.js framework that we can use to write JavaScript to power this front-end application and talk to the smart contracts, all right? React is a component-based library that's going to save us a lot of time and headaches in order to develop the project. And don't worry if you don't know much about React. I'm going to show you everything step by step in this video. Now I'm going to close this out because we've verified that it's set up properly. All right, let's go ahead and kill this. And I'm going to go back to my project and start creating the smart contract. And I'm going to go back to my Truffle project and start creating the smart contract and see if we can deploy a basic copy to Ganache, just to make sure that our project's set up, that this is talking to the blockchain correctly, and that we can indeed actually create a new smart contract. So in order to do that, I'll go to the source directory and find the contracts directory. I'll open this migration contract again, and I'll create a new file here. All right, and I'll call this social, capital S, social, capital N, network, .sol. All right, and that's the extension that we use for the Solidity programming language that we'll use to create the Ethereum smart contract. All right, so this is the file that we'll use to write the social network smart contract. And there's one thing we need to do before we write any other Solidity code. We need to tell this file what version of Solidity that we're going to use. And we do that just like this. All right. We say pragma, Solidity. We use a Curate, and we say 0.5.0. That basically just means any version of Solidity that's version 0.5.0 or greater. All right. Now, we're going to create the smart contract like this. We'll use the contract keyword, say contract, and say social network. And then we'll use some open and curly braces. And we'll put the rest of the remaining code inside of here. Now inside of here, I just want to implement some really basic behavior to ensure that we can actually create smart contracts, put them on the blockchain, and interact with them in the console, right? I don't want to do anything fancy. I just want to make sure that the project is set up properly. So what I'll do is create a variable and assign a value to it, and then try to read that value from the blockchain, all right? So I'll do that like this. I'll create a new variable called, say, name, all right? And we can, create the variable like this, but in Solidity, you must declare the type of the variable before you create it. So I'll say string, all right, so string name. So that's the next thing. And we need a semicolon after each line. So I'll put a semicolon there, all right? Now I want to set the value of this variable. I'm going to do this inside of a constructor function, all right? A constructor function is a function that gets run whenever this smart contract is initialized or created. That's basically whenever it's put on the blockchain. And we can create the constructor function like this, say constructor. All right. That's the special keyword for this function. And we can put the code for it inside of here. And we'll just set the variable value. We'll say name. We'll say equals. Say Dapp. University, social network. All right. And then we need to also add a semicolon at the end of this line, just like we did here. All right. So next, we need to modify this constructor function with a special keyword called public. All right, so what does that mean? It essentially means that Solidity needs to understand this function is accessible to the public interface for the smart contract. Essentially, this function can get called outside of it, and it is going to get called outside of it whenever this contract is deployed to the blockchain. That's when this constructor function runs, okay? Now, Solidity supports other types of functions inside the smart contract that wouldn't necessarily be public, but this one needs to be public. All right, so we have created a way to store the name, and we have set the value for the name inside the constructor function that's going to get called once and only once when the smart contract is run. So now we need a way to actually read this. We have the variable value, but we can't read it yet. We do that just like this. We say string public name, all right? And what that does is give us a special function for free inside of Solidity that will return this value, okay? So whenever we talk to this smart contract here in a minute, we'll be able to read this name value with a function called name. Even though we haven't explicitly defined a name function, it's going to give us one for free. Also, this variable is special because it's called a state variable, which is different from a local variable, which you might just see inside of a function. Instead, this state variable belongs to this entire smart contract. And it's special because its value gets stored on the blockchain itself. It doesn't just stay in memory. So whenever we write this name value, Dapp University Social Network, the value of this variable is actually going to get written to the blockchain. All right. So that's all we need to do for our basic test. Okay. So let's go to our terminal and see if this compiles. We'll just say truffle, compile. All right, I'll go ahead and bump this up a little bit. We'll see if there's any errors in our code. All right, looks like it worked. So there are no syntax errors with our Solidity code. So we can see that a new file was created here inside of source ABIs, and we can see a social network .json file. So this contains an ABI, which is essentially just a JSON description of how the smart contract works inside this file. Essentially, it's just describes the functions and the values and all the behavior that's associated with this smart contract. Okay, so the next thing we want to do is put this smart contract on the blockchain. We want to put it on Ganache. Let's see here, Ganache right here. So we need one more file in order to do that. We're going to create a migration file. So at the top level of your project, go inside the migrations folder, and you'll see a file called one_initial migrations. Okay. So I'm going to create a new file inside this same directory. We'll call it 2_deploy_contracts. All right. So this is going to create a new file that's going to get run whenever we put new smart contracts on the blockchain. And I'll explain what a migration file is. So if you've ever used another development framework, maybe you've built a mobile app or you've built some other web application or really any kind of app that uses a database, you've probably seen some sort of migration file. And a migration just means that you're moving something from one state to another, right? That can be moving data from one state to another, from one place to another. In this case, we're putting our smart contract on the blockchain. We're moving it to a new place. And it also means that we're updating the blockchain's state from one state to another. So that's what a migration file is. It creates new smart contracts on the blockchain. So I'm going to copy the code from this initial one and just paste it in here as a starting point. And I'm going to edit it. So I'm going to highlight all the instances of migrations and type in social network. All right, this is the same name as the smart contract, all right, which is coming from here. All right, social network. And Truffle uses something called artifacts to get this value, all right? And the artifacts essentially come from these files inside of this ABIs directory. Okay, so this is the artifact that Truffle uses in order to create the deployer right here, in order to do this migration. And I'll also note that this file is numbered because Truffle has to know which order to run these migrations in. Okay, now that we've created that, let's go ahead and run the migrations and put this smart contract on our Ganache personal blockchain. I'll go to the terminal, and from the project directory, I'll run truffle migrate. All right, it worked. So we can see that the smart contract was put on our development blockchain. Now let's try to interact with it in the console. I'm going to open the console like this. I'll say truffle console. Now we have access to a JavaScript runtime environment where we can interact with the smart contract that's deployed to our network, okay? So essentially we can write JavaScript inside of here to interact with the smart contract, which we wrote in Solidity. And I'll show you how we do that. I will fetch the smart contract from the blockchain, and there's a few ways that we can do this. Essentially, we want to use this, let's see here, social network value. So I'll just copy this and say social network, okay? And we can say deployed. All right, and we can see a return value here. So what this does is get a deployed copy of the smart contract from the blockchain. Now, there's one problem. All these calls to the blockchain are asynchronous, which means we have to wait for them to finish, right? And because of how JavaScript works, I can't really just assign this to a variable. I can't say contract equals social network.deployed. That's not actually going to return the value because JavaScript is going to return a promise here because it has to wait for this to finish. So there's a few ways to handle this. One way would be to do this. .deployed, and then pass in a callback function, say then, right? And say, contract, and then contract equals C. You can say contract, okay? That's one way of doing it, but I'm actually going to use the async await pattern. So there's a lot of ways to do this in JavaScript, but I'm going to propose the async await pattern because I'm going to use this heavily inside of the test suite whenever we write tests for this smart contract as well. So in this case, I'll say contract equals await social network dot deployed. All right. And now I can fetch the value like this. Okay, we can see it's the same value that was returned, but this is just a shorter way of doing it. And this is a pattern that I'm going to use repeatedly whenever we develop this smart contract on the client side and also in the tests. Okay. All right. So we have a copy of the smart contract. We can inspect the address on the blockchain. Contract.address. Oops, sorry. 2 S's. There we go. There's the unique address of the smart contract. This tells us where it's located on the blockchain. If you have this address in the ABI, you can, interact with it. The next thing we want to do is try to read the name, just like we said here. All right. And we can also fetch that value like this. We can say name equals await contract.name, because we also have to wait for this to finish because it's an asynchronous call. So name equals await contract name. All right. You'll notice this says undefined here. We simply need to return the name by retyping the variable. Say name, hit enter. There you go. Awesome. Dapp University social network. So it worked. The value is set whenever the contract was deployed to the blockchain, and we can successfully read the name with this public variable value. You can see that Solidity gave us this reader function .name for free. All right, so we successfully set the entire project up. We've started a blockchain, right, that has some accounts with some Ether. We've created a client-side website, which we're going to develop out later. But, we started this web server here. We've, started our smart contract, and we have deployed it to the blockchain. And we talked to the smart contract inside the Truffle console. So congratulations, you're off to a great start. In the next section, we're going to continue building out this smart contract and actually set up a test suite that's going to allow us to iterate on it and add new features. All right, so let's go ahead and go to that next section. Now let's continue building out the smart contract for our social network. I'm going to do this by writing the source code here, with Solidity inside this file. And then I'm also going to simultaneously write tests that check that our code actually works while we're developing it. And I'll do that in a separate file written in JavaScript, just like we used here in the console. So let me explain why I'm doing this. It's going to save us time. Writing tests while we write the source code means we don't have to go back to the console and check that our code works every single time. I showed you how to use the console here by, checking the name, but let's say we added another function and we wanted to make sure that function worked and also the name worked. Well, we don't have to go back to the console and, call the name again and then call the function and keep doing that every time we, change our behavior. We're going to automate this process by creating a new test file that can, ensure that our code works while we're building new functionality. And I'll put that file inside of a new directory. I'll go to my terminal and I'm going to exit the console, say exit. Okay, so I'll create a new directory for our tests. I'll say mkdir, I'll say test / All right, you can see in my editor that a new test directory was created here. Now I'll create a new file for the test. I'll say touch test / capital S social, capital N network.js. All right. So now we see a new file, and this is where we'll actually write all of our tests. So I'm going to use 2 tabs here. And you do a 2-column layout. I'll put the source code here for the smart contract, and then I'll write the test in this side. We're going to write our tests in JavaScript, and we're going to do that with the help of 2 libraries that come bundled with the Truffle project. The first is the Mocha testing framework. This is going to allow us to write test examples, which we'll see here in a minute. And we're also going to use the chai assertion library. All right, this is going to allow us to write test assertions. You can see assert equal. All right, so we'll see plenty of examples of this, but just know that we're using these 2 libraries while we're writing our tests. And also, I'll mention another reason why testing is so important. It's critical to ensure that our smart contract code is perfect before we deploy it to a blockchain. Remember that you can't actually update smart contract code once it's on a blockchain. All right, once you've deployed it, it's there forever and you can't change it. And that's what makes it a smart contract. It's immutable, it's unchangeable. So we want to ensure that we don't have any bugs before we put them on the blockchain, and our tests are going to help us do just that. So let's get started. First, inside this file, I'll import the smart contract just like we did in the migration file. I'll do this. I'll say const social network equals artifacts.require, and then we'll say social network.sol. Again, you can just copy this line, let's see here, from the migration file. All right, this is the same, okay? That's going to bring the smart contract into this file. Next, I want to require the chai assertion library. I'll do that like this. I'll say require chai, all right? And then I'm going to use require chai as promised. This is also inside of our package.json file. And I'm going to call should, okay? So this is the same thing as just putting these all in the same line, but I'm going to break it up so that it's easier to read. All right? So now we can create the skeleton for our test by saying contract, all right, and then pass in social network, just the name, and we'll pass in a callback function like this. And then we will write all of the code for the tests inside of here, okay? This callback function has a variable which is going to contain all the accounts that were provided to us by Ganache. So this variable is going to be an array that's going to be all of these accounts right here. Okay, and we can use those accounts as examples inside the test. Okay. So let's go ahead and write a basic test to see if the smart contract was deployed to the blockchain. First, we'll say let social network to keep a copy of it. This is the variable that we'll use to represent the deployed smart contract. And we'll say describe deployment. All right, and then I'll pass in a function. And what I want to do here is create an example and just say it deploys successfully. All right, and then I'll also pass in a function here. All right, so how do we check to see that it was deployed successfully? Well, remember inside the console, we returned the address. So what we want to do is assume that if the address is there, then it deployed, okay? Remember from the console, we did that just like this. We said social network equals await social network dot deployed. All right. Now we've already declared social network here with let, so we can assign this variable value. All right. But in order to use this await keyword, it has to be called inside of an asynchronous function, hence the async await pattern. We didn't have to call the async keyword inside the truffle console. It just works natively. But inside this test suite, we have to add an async keyword here. And then we're also going to put it here. All right. This is going to allow us to use this await keyword inside this function. Otherwise, it's going to blow up on us. All right. So now let's check for this address, just like we talked about. We'll say const address equals await social network, lowercase social network address. Okay. And then now we want to make sure that the address is not blank. I'm going to do that just like this. I'll say assert not equal address 0x0. All right, we'll move a blank address. And then I'm also going to check to make sure it's not an empty string, it's not null, and it's not undefined. So I'll do that just like this. Boom. So that's how we write the assertions. Just assert not equal, pass in the first value, and then compare it with the second value. So address right here, and then 0x0. It's not empty string, it's not null, and it's not undefined. All right. So now let's just run the test and see if it works. Go to the terminal and say truffle test. All right, it works. Boom. We've got a working test suite. Let's continue creating some more tests. First, I'm going to create a new example like this. Say it has a name, just like we did here. And then I'll pass another function, async, and say const name equals await social network name. And then say assert equal, right? Not equal, but equal. Say name. And we'll say Dapp University social network. All right. So we got one problem. We don't have an instance of social network yet. So I'm going to remove this because I don't want to have to do this every time. Like I might have to say, this, which I don't want to do. I want to do it twice as I continue writing more, test examples outside of this later. So what I'm going to do now is say before async, and then pass in social network equals await social network deployed, and then remove it from here. This is going to reduce duplication, and it's going to allow us to, keep checking this variable value after we create more specs or tests after this deployment description, okay? So I'll save that, go back to the terminal, and let's run the tests. All right, it passes. Awesome. So we have our test suite set up. So now let's go ahead and continue building out the rest of the smart contract. Let's make a quick list of everything we want the smart contract to do, okay? We'll say it must create posts. All right, these are the social media posts. And then it also must list all the posts. All right. And then it also must tip posts. Okay, these are the three core functions that we want the smart contract to do. Okay, allow people to post, see all the posts people have created, and then allow other users to, tip the post with cryptocurrency and make those posts, appear more relevant. Okay, and then whenever the tips are created, the authors will receive the tips. So in order to do that, let's go ahead and just write this out as a list over here in our tests. We'll just say describe posts. So I'm going to give us some space here. And I'll pass in this asynchronous function. All right. And here I want to create, three examples that, describe all the behavior, right? We'll just say it creates the posts, it lists all the posts, and it tips the posts. All right, boom, there we go. Those are the three core examples that we're going to use whenever we're developing out the smart contract. And this describes exactly what the behavior is going to be, right? This list is just, moved over here. It creates posts, it lists posts, and it allows users to tip posts. So let's focus on this first part. It allows, users to create posts, okay? So the first thing we want to do is create a function that allows users to do this. So let's hit enter and say a function. All right, that's the keyword that we use inside Solidity. Say create post. All right, so here's, just a basic function structure. But we need more than just this. We can write all the code for creating the post inside of here. But we need some content. We need an argument. Okay, so whenever someone creates it, they're going to have a variable called content. That's just going to be some sort of string like this. If you're posting your status on a social network, that would be the content of the post. And we'll put that inside here like this. Say string content. Okay, so this is going to be a local variable that's different from this state variable, right? This is just an argument passed into the function, and we'll have access to it inside of here just like this, all right? Content. So you'll notice this looks slightly different from the state variable. It has an underscore. That's just a naming convention used when writing Solidity code that comes from other languages as well to let you know that this is a local variable and not a state variable, okay? So it's nothing special. You don't necessarily have to have this here, but I do it just so that it's easy to read and know that this is a local variable, not a state variable. So next, we also need something called memory here. All right, this is just a modifier that Solidity requires us to use whenever passing this in. And we also want to be able to call this function outside the smart contract. So currently, if we try to call this from our test or in the console, it wouldn't work because we have to declare it public. Just like this, all right? So once we pass in the content for our post, we need to actually, create a post itself. So how do we do that? Well, I'm going to use something called a struct in Solidity. So Solidity allows us to create our own data structures like this. We can use a struct keyword, all right? And then we can call it anything we want to. So I'm just going to say post. And then we can use some curly braces just like this. And we can define all of the attributes for the post. It's really simple. You just say uint ID. All right, this is going to be the unique identifier for the post, just like an ID inside of a database. And this is going to be, say, string content. All right, that's where we're going to store this value here. All right, then next, we'll say uint tip amount. All right, this is going to be the amount of tips that someone can give, and we can update this. And then next, we want to say, we want to keep track of who the post author is. In this case, this is going to be an Ethereum address, just like the username. So we'll say address, author. Okay. So I'll make a mention of this. The uint just stands for an unsigned integer. That means this has to be an integer value that can't be negative. That's what unsigned means, right? So, an integer could be like 1. A signed integer might be -1 because it has a sign in front of it, but we don't want it to do that, right? And then, string is pretty self-explanatory. And like I said, address is just like the addresses we saw in Ganache. These are like the users on the network, okay? So that's how we model the post. we create a struct that has an ID, has content, tip amount, and author. That's all the data we need to store a post. Now that we have this, we can actually create a new post inside of the function, just like this. I'm going to move these tests over momentarily and give ourselves some more space here to work with. So we could create a new post just like this. Just say post, all right? And then this is going to allow us to pass in all these arguments, the ID, the content, the tip amount, and the author, all right? So we can just say, for right now, I'll just hard code and say ID equals 1. We're going to change this momentarily, but I just want to show you how this works. So we can say ID, say content, which is going to be the content passed in here. And then the tip amount, whenever we start, is going to be 0. So I guess I got to do that as well. Say 1. All right, so ID 1, content, tip amount is 0, and then the author. So who is the author? Well, Solidity gives us access to a global variable called message, or MSG, and this has this allows us to read some other arguments, one of which is sender. All right, that's how we find out the person who is calling this function. So this is a special argument essentially inside this function that we don't pass in here, right? You don't see it, but we can actually declare who the sender is, who's calling this function. I'll show you that in the test here in a second, and that's going to tell us who the actual post author is, whoever called this function. All right, so that's how you create a new post struct. So we need a place to put this, actually stored on the blockchain. This just instantiates it. Whenever we create this, it just gives us a new post, but it doesn't actually save it. So how do we do that? Well, we're going to use something called a mapping. All right. So Solidity allows us to create something called a mapping like this, say mapping. And a mapping is essentially just a key value store that allows us to store data. Okay. And because I'm declaring this mapping here, it's going to be a key value store that actually writes information to the blockchain itself. This is going to kind of help us treat this smart contract like a database with the blockchain. So it works a lot like an associative array or a hash in other programming languages. So you can say uint and then say post. All right. So this is the key. This is the value. The uint is going to be the ID of the post, just like this right here. And then the value is actually going to be a post struct. All right? So that's how we'll store this on the blockchain. And we can add the post to the mapping by first creating a posts variable. All right, just like this. So mapping posts is going to be a structure that stores posts like this, uint posts, all right? We can also declare this public so that we can fetch posts from the mapping later, just like we did with name. All right, this is going to be give us a reader function, or we can pull this information out of here, like name, posts. So we could have a post function, pass in an ID, return the post. So now let's actually add this post to the mapping after we've created it. We'll do that just like this. We could say post equals post like this, and then say posts, and then we want to give it the ID where this post is going to get stored. In this case, if the first time we call this function, it'd be 1, all right, just like 1. This is the same ID. And then we'd say, let's be explicit about this. ID equals 1. Say ID, all right, just so you see where it's coming from. And we just pass in the post like this. All right, so sorry, I want to change that. So post equals the newly created post, and then we put the post inside the mapping just like this. The key is the ID, right? The same ID here. And then the value is going to be this post itself that we just created. All right. So that's all the basics that you need in order to actually create the post. So I'm going to change this a little bit because we don't want to just hard code this ID. We actually want to, create a new ID anytime a post is, created. I'm going to do this with a counter cache. which will look like this. We'll just create a new variable at the top. So under name, I'll say uint, it's going to be an unsigned integer, public, post count. All right, and this is going to initially equal 0. So what this will do is keep track of the number of posts that get added to this mapping. All right, and I'll do that like this. I'll say post count, and I'll increase the value by 1 whenever we call this function. All right, so the first time we call it, post count is initially going to be 0. All right, and after we increment it, it's going to be 1, and then we can use that value as the ID like this. All right, and then also here. So the post count essentially will be the ID once we've updated it right here. And then every time we call this function, it'll increase, right? The next time it'll be 2, the next time it'll be 3, and so on and so forth. All right. So I'll say increment post count. And that's what this plus plus means. It means just add 1 to whatever the previous value was. The first time it'll be 0, then it'll be 1, then 2, etc., etc. All right. The next, we'll say create the post. And now what I want to do is, make this a lot simpler. Instead of doing this on 2 lines, I'm going to do it on 1 line. All right, so we've got post count here. Instead of assigning this value to post first, I'm going to do it in one shot, just like this. Say, boom, done. All right, so this will just create the post struct and add it to the mapping all in 1 line. So here's the post mapping, here's the ID, which is the key, and then the value, which is the post, just like this. Boom, done. That creates the post and saves it on the blockchain all in 1 line. All right, awesome. So let's go ahead and write some basic tests for this. We're going to add a few more lines to this function, but I want to focus on the test suite for 1 minute just to make sure that we can get this rolling. So first I'm going to call this function inside the create post example. All right, I'm going to say social network. All right, we have a copy of this already because we created it here inside this before hook, right? So say social network create post, all right, just like we did here with name. And then I'm going to pass in the value for the content. All right, so I'll say this is my first post. Okay, so that's basically how you would call a function inside Solidity. But we need to specify who the author is. Okay, so remember I talked about this msg.keyword here, msg.sender. We need to know who's actually sending this function. So we do that with function metadata. And from the client perspective, right, inside JavaScript, we pass in function metadata after the regular arguments, right? This function just takes 1 regular argument, but it takes an optional object after that. And this is where we'll add all of the function metadata, okay? So we'll say from, and this value right here, from, is going to correspond to msg.sender. All right, so from equals msg.sender on the Solidity side. All right, so here, how do we pass in the address for this? Well, if you remember a minute ago, I talked about the accounts getting included inside of here, right? You can see all of the accounts in Ganache right here, all right? So I can also break this out. We could read account like this. We could say accounts 0. We could fetch it out of the array. But instead of doing that, I'm going to actually specify the account that's going to be called here with a specific variable. So I'll use an array here instead, and I'll list out 3 different accounts that we're always going to refer to inside of this test example. All right, we'll say deployer. This is going to be the account that actually deploys the smart contract to the blockchain. I'll say author. All right, this is going to be a person who creates posts. And then I'll say tipper. This is going to be a person that creates tips on posts. So, social network create post. This is my first post from author. Boom. So that's going to be the address of the person who's creating the post. And that's exactly who's going to correspond to msg.sender right here, which is going to get saved as the author value inside of this post mapping. All right. So let's call that inside of our tests by saying await. All right. And then we'll say result equals that. And in order to access this value on down the line, I'll say let result. Okay. And then next, I want to ensure that the post was created. So I'll say post count equals await post count. All right, we can say post count here. And so essentially, we want to dig into this result and see, that it was created and that the post count increased. So those are the two conditions we're going to check whenever it creates the post. So how do we do that? So first, let's just do a basic check that the post count was increased. So we'll just say success. And we'll say assert equal post count equals 1. Because remember, it was initially 0. But now we want to make sure it's 1. Okay. And I'm going to go ahead and just do one pane here. So save that on the test. Say truffle. Test. Oops, looks like we had a little problem here. I forgot to finish writing this line. So post count equals await social network dot post count. All right, sorry about that. So let's save that, go back to the terminal, run truffle test again. All right, it passes. So this is a little misleading. These aren't really passing, so I'm going to comment them out for now. Just comment out like this. All right, that way we won't have this misleading information whenever we run the new tests. Okay, so the post count was increased. So now we want to actually dig into the post and actually ensure that the values are set correctly. So we need to write some more code in order to do this. So Solidity allows us to create something called events. All right, they get triggered whenever we call them. So I'm going to trigger a new event here. And we're creating this event to track the values that were stored inside of the post, okay? These events can be triggered from Solidity smart contracts and subscribed to by external consumers. The external consumers can listen for them and get the information from the event and do stuff with that information. And that's exactly what we're going to do inside of our tests. We're going to subscribe to the event and read its values and check that the data is correct. And that's exactly what was, in the post. So let's create a new event inside of Solidity like this. It's pretty easy. We just use the event keyword, say event, post, created. All right, we use open, close parentheses with a semicolon. And then I'm going to use new lines here. So I'll say uint ID. It's going to be the same values, but we'll use commas instead of semicolons. We'll say string content. We'll say uint tip amount. And we'll say address author. All right. So we can trigger the event pretty easily inside Solidity. We'll just say emit post created. All right, say post count, say content 0 msg.sender. It's basically the exact same values we passed into the function. So let's just run the test again and make sure everything works. We didn't break anything. All right, it works. So now we can go back to the test and log out this result. And this result is going to contain the information for the event itself that will allow us to verify the data from the post. So I'll just do this. I'll say console.log. Let's see here. Result. All right. So I'll save that and see what it looks like whenever we run the tests. And this will show you the structure of the result. We can kind of inspect it and then see the information we want to pull out of the result in order to verify it. All right. So here's the result. This is an object that has a transaction. It has a receipt, and we want to dig into this receipt to get this value here, the logs. All right. And the logs is going to contain this event, post created, that we just added inside Solidity. And this event's going to contain all the data from the post itself, okay? And that's exactly what we want to do in order to verify the data. So, like I said, it's an event. So result is, it's a object. So say, result logs, all right? You can see logs here. Logs, all right? And then logs has, is an array. We can get the first item out of the logs, all right? So it's a zero-based index array. And then args. And this is going to be the event. Say const event. Boom. Now the event is going to have, let's just go ahead and log the event and show you what's inside of it. So I'll do that again. Run the tests. All right, so here's the values that are inside the event. It's got the ID, the content, the tip amount, and the author. All right, so we can inspect all those values just like this. We can inspect that the ID is correct, that the content's correct, the tip amount, and the author. We'll do that just like this. Boom, done. Assert equal event.id to number, all right, because it's a big number in JavaScript. Post count to number. ID is correct, all right. So post count's here, and here's the event ID. Event content, we want it to be, this is my first post. Event tip amount should be 0. Event author should be the same author that created it. All right. So save that, run the test. All right, it passes. So the next thing we want to do is add a final bit of behavior to this function. We want to ensure that the post actually has, some content inside of it. We don't want somebody just creating blank posts on the blockchain. All right. So we can do that like this. We can create a failure case. This is a success case. And we can say failure right here. Post must have content. So we'll say await social network dot create post. Let's just copy this. And we'll take this off. And we'll do empty content from author. And we should say should be rejected. This should fail. Okay. So currently it won't fail, but we want to create the test where it will. So we'll go to the source code and use something in Solidity called a requirement. Okay. So we'll say require valid content. All right. So there's a special function in Solidity called require. And whenever this function is called, it checks for true or false, okay? So if it's true, then this is okay? This function won't do anything else, and the rest of this will continue execution. But if this evaluates to false, this will stop execution, and none of this code is going to get called, okay? And also any gas that gets used in calling this function will be refunded back to the caller. I'm going to make a mention of gas here in a minute. I know you haven't talked about it much, but I'll revisit that topic here in a second. Okay. So essentially what we want to do is require the content is valid. We want to create an expression that's going to evaluate to true if it is valid and false if it's not valid. So that's pretty easy. We can just say bytes content. All right, this just takes the content, which is a string, and converts it to a bytes array. And say length, we say is greater than 0. Boom. Essentially, we're just checking that this string actually has some content inside of it. If it does, as a bytes array, it's greater than 0, then it'll be true. This function will continue execution. And if it's not, it'll be false, and it will stop, and none of these, will be executed. So let's run the test, see if it works. All right, it passes. All right, so that's it for this section. We've done a lot of work so far. You've created a new function inside the smart contract to create posts. You've learned about mappings and structs inside Solidity and all kinds of good stuff, right? We've written tests. You've covered a lot of ground, so you should be really proud of yourself, all right? We're going to revisit some of this code in the next section, talk about gas, refactor some of this, and we're going to move on to listing out the posts and also creating tips. All right, so let's go on to that next section. All right, so let's go back into this smart contract, right? In the last section, we created posts with this function. We want to do a few things inside this section. We want to continue out our tests. We want to, list the posts and then allow users to create posts. So we'll create, a function for that also inside this smart contract, okay? So while I'm here, I want to clean things up a little bit and make a mention of a few things. At the end of the last section, I mentioned gas. So this is a topic we haven't talked about much yet in the tutorial. So what is gas? Well, I'll explain it this way. Anytime you write new information to the blockchain itself, you have to pay a gas fee, all right? So anytime you send cryptocurrency from one account to another, you must pay a transaction fee for doing this. Likewise, anytime you create a smart contract or you call a function that actually updates the blockchain itself, you also have to pay a gas fee. So whenever you're calling functions inside Solidity, there's two types. There's reads and there's writes. So reads are free, but writes cost gas because they actually change the blockchain. And anytime you're sending cryptocurrency from one account to another, they also have a transaction fee associated with it, and they cost gas. All right, that's what this is. It's basically a transaction fee paid in Ether, the Ethereum's native cryptocurrency, and you must have Ether in order to create transactions on the Ethereum network. Okay, and so if you notice, if you open Ganache, you'll see that the balances have gone down. Right, so there's 99.85 Ether, 99.98 Ether. They used to be 100. Well, why is that? Well, this first account right here is the deployer. Right, if you go to our test, you'll see this is the deployer. This is the first account in the list, right? This is the deployer. This is the tipper, the second account in the list, or sorry, the author, second account. And then this is going to be the tipper, all right? So the tipper hasn't created any transactions yet, all right? But the author has. So whenever the author was creating his post, he created a transaction on the blockchain, all right? And this cost a gas fee. Same for the deployer, which happened every single time that this function was called. It also had to pay a gas fee, and that's why this account balance has gone down. You see it's less Ether than the rest of these, okay? And then as soon as we create the tip functionality, the tipper's account balance is also going to go down by the tip amount and also the gas fee. Now inside the test, let's go ahead and do a little cleanup. So you'll notice that I used a before hook here before we did the deployment. I'm going to do the same thing for the post, okay? So just before this, creates post, I'm going to move this up a line, just like this, and I'll use a before hook. I'll say, boom. Before async, result is equal to this, right? So we'll track the result in the post count inside of here rather than doing it here inside the example, because we want to use these values, result and post count, inside these examples like this. All right, so I'll uncomment this out. And now inside of here, we'll be able to access, the result and the post count as well. So now in order to test for this, for listing posts, we're going to call the post function, okay? Just like this post function right here. And we're going to pass in the post count from this right here. And we're going to, read all the values and ensure that the post has, the correct values, just like this: ID, content, tip amount, and author. So I'll say const post equals await social network dot posts. All right, pass in the post count. This will be the latest post. And now we can inspect the values like this. We'll just copy this right here and then paste it in here. Boom. So instead of event, we'll say post dot ID to number is equal to the post count. All right. That the content is equal to the content, tip amount, and author. Okay. So we'll save that, run the test, go to the terminal, say truffle test. All right, should be a new example for listing the posts. Awesome, lists all the posts. Perfect. So this is just a way of fetching one post. And when we create the client-side application and we actually list out all of the posts, what we'll do is use the post count and use a loop to check each post individually. We'll call this post function and fetch it with this function just like this. That's because we have to do it that way, which I'll revisit later, because in Solidity, there's no way to know how big this mapping is natively, and there's no way to iterate over it either. We can't just say like post.all or post each. We can't just return it. We have to know how many are inside of there, and then fetch each one out individually with this post function. And I'll show you how to do that whenever we create the client-side app later. But for now, we know that we can fetch a single post. And if we can fetch one, we can fetch all of them. All right, so let's go ahead and move on to the last part of the smart contract for the social network. Let's do the tipping functionality. So this is the example we're going to use here, okay? So inside of here, we're going to create a new function called create tip, or tip post, I should say. Say function tip post. Say uint ID. We're going to pass in the ID of the post we want to issue a tip for. And we'll write all the function code inside of here. This post is also going to be public, just like the other one, because we want to be able to call it from the test and call it from the client-side application. All right. And this function needs to do a few things. First, it needs to fetch the post. Then it needs to fetch the owner from the post, or the author, I should say. Increment the tip amount on the post whenever the tip comes in. I should update the post. It should pay the author. And then finally, it should trigger an event. That's a lot of stuff. And tell you what, let's actually pay the author up here before we increment the tip amount. So let's see how that works. First, we're going to fetch the post from the blockchain. All right. So we can fetch it out of this mapping, right? You could say posts. And then pass in the ID right here. All right. That's how we read it, just like we write it. And then we're actually going to store a copy of this in memory. Okay. So we'll do that like this. We'll say post memory post equals post ID. All right. So what this will do is create a new copy of it, and we will, update these values, and that won't actually affect the post on the blockchain. Okay. It won't affect it until we reassign this value here later. Okay. So we'll update the post. We'll go ahead and do it now before we manipulate it. We'll just say posts ID equals post. All right. So we're going to fetch the post, create a copy, and then put it back on the blockchain later. But in the meantime, we're going to, fetch the author, pay the author, increment the tip amount. That's going to change the post itself, and then we're going to put it back here. All right. So we can simply get the author like this. Say address author equals post.author. Pretty simple. All right. And then, we can increment the tip amount and also pay the author. Okay. So let's do that. We'll say post.tip amount equals post.tip amount plus, this value. So we need to add the actual tip that's coming in. Well, how do we do that? All right. This is really confusing because all we have here is one argument so far. We just have the ID of the post that we want to pass in. So where's the actual tip? Where's the cryptocurrency itself, right? We're tipping this post with Ether, Ethereum cryptocurrency, but how do you tell this function that you want to tip Ether? There's no argument for the amount. That's because Solidity allows you to use some more function metadata just like this to track the amount of Ether that gets sent in whenever this function is called, okay? So we can say msg.value. All right, this is going to be the actual amount of ether that gets sent in. And we can update it just like this. So post tip amount is equal to post tip amount plus the amount of ether or Ethereum cryptocurrency that's sent in whenever this function is called. So if you go back to the test, we're going to be able to say value just like we did from, right? So that's another example of metadata, or you can say it like this, value equals ether. Okay. All right, we'll see that here in a minute when we go back to tests. But for now, we can also pay the author address, and we can pass in the author. And then we'll call a function called transfer. So this is a Solidity code that tells us to send ether to this author right here inside this function. And we'll just say msg.value. We'll say pay the author by sending them ether. Okay? Boom, done. And then lastly, we want to trigger an event just like we did here. So post created, we want to say, post tipped, all right? So we'll create a new event just like that. We'll just copy this post created and paste it below. Say post tipped. And we'll use the exact same arguments: ID, content, tip amount, and author. So there's one more thing we need to do in order to pay the author. We need to change how this function works. In order to create a function in Solidity that accepts ether, we have to call it payable. Say payable, right? We add that modifier right here. That will allow the user to send in Ethereum cryptocurrency whenever they create this transaction, which we'll see here in a minute. All right. Likewise, we also need to say that this address for the author is also payable. Okay. We're going to do that in a few different places. First, we'll do it here. We'll say payable, address payable, author. All right. We'll also do it here inside of the post. So address payable. This is a special data type. Address payable author. And then also address payable author here. All right, that should be everywhere that we need to change in order to actually pay the author here. All right, so let's save that and go back to our test. Let's write a test to see if this works. And I want to go ahead and call the tip function and basically tell it how it works. So I'll say result equals await social network dot tip post, and then I'll pass in the latest one. So we'll say post count. All right, and then we're going to pass in the metadata. So we need to tell it who's going to do this. So previously we did from author. I'm just going to copy this and paste it here. In this case, it's going to be from the tipper. All right, so I'll copy that and paste it here. And next we want to send in some Ethereum cryptocurrency with this metadata that's going to get interpreted here as msg.value. So just like this was from, went to msg.sender, in JavaScript, value is going to correspond to msg.value, right? And that's what this message function metadata is, okay? So now we want to tell it how much ether we want to send in. So let's tip the post, 1 ether. Let's just be really generous and give him an entire, 1 unit of Ethereum cryptocurrency. Now, we don't want to just say 1, right? That's not actually ether. So why is that? Well, Solidity uses something called way to store all ether values. All right, let me explain what that is. So 1 ether can be divided into 18 decimal places. All right. That means 1 followed by 18 zeros. All right. So essentially like a US dollar can be divided by, 2 decimal places. It's 1 followed by, 2 zeros to determine how many cents or how many pennies make up $1. This is a similar kind of thing. This is how many Wei make up 1 Ether. This is sort of like a really tiny penny in Ethereum. This is the smallest unit of the Ethereum cryptocurrency itself, okay? So all the values inside of Solidity for Ether are stored in Wei. That's because we don't use any floating point numbers to store on the blockchain, right? We just use integers, all right? So if you're going to do that, you can't store any decimal places. You have to store, basically numbers, like integer values. So that's why we use Wei. So anytime we see something like msg.value, this is not going to be an Ether value, it's going to be a Wei value. So if you want to say 1 Ether, 1 Ether is going to be, 1 Ether is going to equal, 1 followed by 18 decimal places, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 Wei, all right? So if we send 1 Ether in when this function is called, we're sending in exactly that many Wei. Okay, so there are some utilities that help us do this. So you can't just say 1 here is value. You actually need to say, this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. But that's kind of crazy, right? We don't want to do this every time we want to just say 1 Ether inside of our tests. So luckily, there are some helpers that we can use. We can use the Web3 library, which is included inside this test suite. We're going to use Web3 a lot when we create the client-side application, and you're already using Web3 under the hood. We can say web3.utils.toWei. All right, we say 1 and Ether, right? And that's going to convert this to the Wei value and give us, 1 followed by 18 decimal places without us having to write all that out ourselves, which would be kind of ridiculous. All right, so that's how we tip the post. We tell it the post we want to tip, we tell it who the tipper is, and then we tell it how much cryptocurrency they want to send. In this case, it's 1 Ether, which is going to be 18, or 1 followed by 18 decimal places Wei. All right, so after the tip is issued, we're going to guarantee its success, just like this. All right, say success, and instead of the post count changing, we're just going to dig into the logs and check that the ID of the tip was correct, all that kind of stuff. So that's fine. ID is we'll just use this same template from this. We'll say ID content. So tip amount is going to change. All right. So we'll just be explicit about it in this case, just so that you can see what's happening. We'll say 1 followed by 18 decimal places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That's the tip amount. All right. Tip amount is correct. And then the author is also correct. So the tip amount should have changed whenever this happened. All right. Okay. So let's just save this, and that'll be our first check. So I'll say trouble test. All right, it looks like we had a little bit of a compilation issue. So I'll go back to the source code, and yeah, I forgot to do this. Say post underscore. All right, save that. Run the test again. All right, it looks like we have one more problem. It says, can I read property args of undefined? So I know what this is, but I'm going to reason through it for a second, just so that you all can understand. So this says that args is undefined. Well, that's because there's no actual event listed here. That's because we forgot to trigger it inside this function, right? We left a note for ourselves to trigger the event, and we created it, but we never actually called it, okay? So we got to trigger the event, and we'll just say, post tipped, right? And boom, post tipped. Pass in the count, the content, tip amount, and author. Save that. Run the test. All right, it passes. So we're getting really close. The next thing we want to do is check that the author actually received the tips. So what I'm going to do is essentially check the author's cryptocurrency balance in their wallet before the tip was issued, and then also check it after the tip was issued, and compare the two, and just make sure that the new tip amount is bigger than the old one. All right. So I'll just say track author balance before purchase. I mean, this is a little faster, but I'll explain it because I want to move on. Say boom. All right. So let the old author balance equal this. So we'll say Web3 ETH get balance. That's how you check the balance of someone's wallet. All right, passing the author. And then we're going to convert it to a big number, all right, in JavaScript like this. Web3 utils big number, old author balance, all right. And then what we want to do is check that the author actually received the funds after this success. So we'll say success. Sorry, I moved this too. Say boom. So new author balance. So here's the old author balance, new author balance. Same thing. We just check the balance of the author again. All right. Just like we did here. And then now we're going to factor in the tip amount. Say boom. Let tip amount equals this. Web3 utils 2-way, 1 ether. And I guess we could refactor this up here. But we'll just leave it for now. And now what we'll do is say expected balance equals these two things added together. Boom. So old author balance, add tip amount. All right. So you can pause this on your screen if you want to try to make sense of this more. But finally, what we want to do is compare the two, the new author balance and the expected balance. And we want to say that they're equal. Boom, like this. New author balance to string. All right, we're going to coerce these to strings and say expect is equal to the expected author balance. All right, so you can pause this and take a look if you want to. All right, so I'll run the test. All right, it passes. Finally, I want to ensure one more test case. We want to fail, say failure. So ensure, so say tries to tip a post that does not exist. So essentially what we want to do is ensure that a valid ID is passed in whenever the tip post function is called. So do that just like this, boom. We'll tip post 99, which doesn't exist yet. We'll do it from the tipper. We'll pass in 1 ether, and this should be rejected. All right, this transaction should not go through because post 99 doesn't exist. We'll do that inside of our smart contract, all right, with a require state, with a require function, just like this. So require bytes constant length equals true, right? For create post, we're going to do a similar thing here for tip post. Boom. Require that the ID passed in is greater than 0 and it's less than or equal to the post count. All right. So if it's outside this range, we'll consider it invalid and we won't let you issue a tip for it. Okay. All right. So that should be it. Let's clear out this space. Do the same thing for our test. All right. Clear out this space. All right. And then say triple test. Say they pass. All right, it passes. Congratulations. That completes our smart contract and the test suite as well. All right, so now that this is done, let's go ahead and deploy this smart contract to the blockchain and get ready to build the client-side application. We can deploy the smart contract like this, say truffle migrate -- reset. And what the reset flag is going to do is put a new copy on the blockchain, all right? Remember, you can't update smart contract code. All you can do is create a new copy of the smart contract. And that's exactly what this just did. It put a new copy on the blockchain and updated the address inside our truffle project to point to the new copy, not the old one, okay? So now you should have everything that you need in order to start building out the client-side portion of the application that we're going to do in the next section. So congratulations, you've done a lot of good hard work. We've got a complete smart contract that we can use to power the social network on the blockchain. So this is great. Now we're going to go ahead and build a client-side application to use this and build out all the user-facing features. So I'll catch you in the next section. Now let's start building out the client-side application for this project. Up until now, we've just been creating these smart contracts that go on the blockchain. All right, that's effectively our back-end part of this application. Now let's work on the front end, which is going to be the website that talks to the smart contracts on the blockchain and allows users to add posts to the social network, see all the posts, and also issue tips for the posts. Okay, so a few quick things. First things first, if you're checking out this point in the video, make sure you have all your dependencies installed. You can just do npm install to make sure everything is there. And also make sure that your blockchain is running. This is Ganache, right? Make sure this is open and connected to your project. And lastly, make sure you have your server started. And well, I guess also make sure you've migrated your smart contracts as well. Remember, we did that in the last video with truffle, migrate, -- reset, okay? So let's go take a look at the website again. Make sure you start your server, npm run start. This should open your browser to the project. So here's where we left off last time. Remember, this is all the boilerplate code that comes with our starter kit. And what we want to do is start, modifying this code to build out our social network website. Again, we've got the Bootstrap templating framework so that we don't have to write a lot of CSS ourselves. And we're also using React.js, which I'm going to, walk you through step by step in this video. So I'm going to go ahead and open up the project code in Sublime Text, and we'll go to the source directory, the components directory, and go to app.js, okay? And let's bump this up so you can read it. This is the main JavaScript file that we're going to edit, all right? So this is, React. This is a React component. So React is a component-based library that allows us to write JavaScript in these reusable components. In this case, an app is a component, and it mixes JavaScript, which is this right here, with HTML code, which is this right here, right? You can put HTML inside this JavaScript code. That's how it renders this onto the page. All right, and you can also see JavaScript is rendered here inside these curly braces, and yeah, that's how it works. So everything inside the return is the HTML that gets rendered onto the page from this render function. Okay, whatever's returned from render gets put on the page. So let's go ahead and edit this. The first thing I want to do is connect this application to the blockchain. All right, we effectively want to turn this basic web app into a blockchain app. So how do we get this app to talk to the blockchain? Well, we use the Web3.js library, right? That's going to be one part. We need to turn our app into a blockchain app. That's what Web3.js is going to do. And then we also need to turn our browser into a blockchain browser. And that's what MetaMask is going to do. All right. So I'll walk you through setting up both of those. We need to connect the app to the blockchain with Web3.js and then the browser with MetaMask. So the first thing we'll do is instantiate a connection of Web3 inside the JavaScript application. Okay. We're going to connect to Ganache, our personal blockchain, and I'll show you how to do that. So the first thing that we do is just import the Web3.js library. We've installed it inside of our dependencies in the package.json file. So we import Web3 like this, all right? And once we're inside of here, we can just load our connection to the blockchain inside of a special function, okay? So I'm going to create a function called load Web3. This will be an async function. So we'll say async load Web3. And inside of here, I want to write all the code that actually takes the connection from MetaMask, right? This thing here, and wires it up to our Web3 and reads it inside of this Web3 connection inside of our app. Okay, so there's no reason to reinvent how you do this. MetaMask actually tells us how to do this, and I've got a link right here from an article put out by MetaMask that recommends the best way of doing this. All right, so you can essentially just copy and paste this inside of your own project, but I'm going to do it basically that way, and also just kind of clean it up a little bit while I paste their idea in. So feel free to check out my completed code on GitHub in order to get this implementation, but this is essentially what MetaMask tells you to do. So don't worry if you don't completely understand this, that's okay. Essentially, all it does is it looks for an Ethereum provider inside your window, and if it doesn't have one, it basically creates a new one with Web3. And if it can't find MetaMask, it'll basically say, hey, there's no MetaMask here, please install it, okay? All right, so that's pretty basic. Don't worry if you don't understand everything inside of there, but that's how it works. So we've defined this function, but we want to call it whenever this component is loaded. So React has some special functions that do some magic. One of them is called component will mount. So we'll say async component mount, all right? And inside of here, we actually want to call this Web3, load Web3. We'll say this. Okay, so essentially what this says is like, whenever this component is going to mount to the DOM, the virtual DOM inside of React, we want to call this function where we load Web3, and we want to wait for it to happen before we do anything else. All right, that's exactly what this does. So let's go ahead and do that. We'll save this, and we'll go back to the page. We can say, let's just say here, yeah, go back to the page, refresh, take a look, and awesome, no errors. So now we have Web3 connected to our app, and our app is now a blockchain application. So let's try to fetch some actual data from the blockchain. The first thing I want to do is fetch the account from MetaMask, okay? So remember, how dApps work or how blockchain apps work is you don't log in necessarily with a username and password. You basically have your username, which is your account, inside of your wallet in your browser like this with MetaMask. So MetaMask essentially is your user management. Your app doesn't do the user management. So we can fetch the account information directly from the wallet with Web3. So I'll show you how to do that right now. So here's the function inside the Web3 documentation. We're going to use Web3, the ETH namespace, and we're going to say get accounts. All right, so this is a function we're going to use. And what this is going to do is return an array of accounts that are available to us from MetaMask. All right, so you can see the example here. Call Web3 ETH get accounts. They're using a promise, or they're using a promise chain, and then, but we're going to use async await. But anyways, this is what it returns, right? This array of accounts. So in our case, we want to get the first account inside this array, and that's going to be our user of the social network who's logged in using the app. So I'll show you how to do that right now. Go back to the application, and I'm going to create a new function called load blockchain data. So async load blockchain data, all right? And the first piece of data we want to load is actually the account itself. So first we're going to get the Web3 connection, which we created. So we said window.web3, right, equals this. So we'll say const web3 equals window.web3. All right, and then we want to load the account. All right. So we're going to use the function we just saw in the documentation, const accounts equals await web3.eth.get accounts. All right. So let's just log that value to the console, console.log accounts, and let's see what comes back. Okay, so nothing yet, and I know why. It's because we defined this function, but we didn't call it, right? We said load blockchain data, but we need to add this to this component will mount function. So after we load Web3, after it's finished, because we wait, we load the blockchain data. So await this.load blockchain data. All right, save that. Try again. All right, there we go. We can see an account listed. Now, you may not see an account just yet. And if you do, it may not be the right one. So a couple things to check out. First, you want to disable privacy mode, or if you do have privacy mode enabled, you want to connect to the application. So here's an article. I can put a link to this in the description. I'll go ahead and copy it and paste it in my notes right now. If you have trouble with your accounts, you might want to reference this because privacy mode inside of MetaMask might be part of your problem. But another thing is you may not actually have imported your account from Ganache just yet. So I'm going to go ahead and do that now. So open Ganache, and let's see here. I'm going to take the first 3 accounts, just like we used from our test, and I'm going to import the private keys into MetaMask. So these are like the passwords. So we'll copy these, and like, don't use these accounts for real cryptocurrency because I've shown them on screen. But I'm going to copy the first one. I'm going to go to MetaMask. All right, and I'm going to import account, private key, paste in the private key, import, and this says I already have done this, so that's okay. I'm going to do it again for each one. All right, copy. All right, so once you've successfully imported all these, I'm going to go ahead and rename them just so that we know which each account is. So the first one is going to be the deployer. The second one is going to be the post creator, and the third one's going to be the tipper. So I'll do that right now. I'll rename this. Go to settings. And let's see here, details. Say deployer. All right. And then I'll go to this one, edit this one as well. See, post creator. And then the last one. Tipper. All right, save that. Now you should have MetaMask properly configured. And I'm going to go ahead and go back to the post creator because the primary account that I want to use in order to interact with the application. So I'll refresh the page, and this address should be the same as the account that's number 2 inside of Ganache if you imported these in the correct order. All right. So that should verify that you are actually connected to Ganache. You've imported it into MetaMask, and that's the account. All right. Now I want to actually list this account out on the page so that we can see, which account we're signed in with whenever we use the application. All right. So what I'm going to do is actually store the address after we fetch it from Web3 right here. Okay. So I'm going to use React's state object. Okay. So React has basically a state that belongs to a component, and this state kind of tells us, what state the application's in. That's a really bad explanation, but I think you'll get the idea when I start implementing it. All right, so we can define a state inside of our component like this. All right, that's what it looks like. So these components have a constructor function as well, and they take something called props, which are essentially properties for the component, just an object. And we want to call super on this. So don't worry if you don't understand that completely. This is just what React tells us to do. But this is what the state object looks like. It's called this.state, and it's just an object, right? It has some values in it. And this value that we want to set is the account. So we'll store the account here, and we'll read this later. All right. So we can store the account like this. After we fetched it with Web3, we'll just assign it to the state. So React has a special function for doing that. It'll say this.setState, all right? And we'll just say account is accounts 0, all right? So let me explain that, right? Accounts was an array that came back from this function, and we would just want the first account in the list. That's the one that we're connected to MetaMask with. All right, and then we just assign this.setState, and we pass in the account and just say it's the first one. Okay. Now, because we've done that, we'll have access to this account with the state object anywhere inside this component, and we can also pass it down to other components. All right. So right now, I'm going to show you how to do that. I'll go to this nav bar. All right. Let's see here. So up here at the top, we're going to create a new section for the address. So inside the nav bar, just after this link, all right, I'm going to paste in a section that we're going to use to hold the account, just like this. All right. So this is just a list item, all right, that is going to show the account. So I can show you what that looks like. All right, there we go. So this is just a component, or not really a component, it's a bootstrap way of doing things where we can just add something to the nav bar that's going to go on the right-hand side, and we can put the account there. So let's go back to the browser. So you can see your account goes here as small gray text, right? So what we actually want to do is display the Ethereum address right here. So we can just say, we can use some curly braces to execute JavaScript inside of here, like this, and say this.state.account. Save that, go back to the page, and boom, there we go. We can see the account listed right there, all right? So now what I want to do is actually take this component and put it inside its own file. We're using one big, React component right now, and I want to break this up into smaller files. So, React components are able to render other React components. So I'll create a new file here in the same directory called navbar, capital N, navbar.js. All right. And so what we want to do is create a new React component inside of here, just like the other one. All right. So it's pretty straightforward. Boom. We just add the new content like this. All right. Feel free to go ahead and pause the video right now if you want to take an in-depth look at this. But what it does is it works just like the other component does. We just import React and component, right? And we give it a name, navbar. And it has a basic render function just like the other component. And we put all the HTML and JavaScript for the navbar inside here. So we'll go back to our navbar, find this nav element. I'm going to just copy it, or cut it actually, and paste it inside of here. All right. So we'll do that. And inside of here, what I want to do is render it out. So in order to do that, we have to import that component we just created. Go to the top of the file, and let's see here. Let's do it just after this. Let's say import navbar, all right? And now we want to render the navbar out on the page, and we'll do it just like this. Scroll down, find where the navbar was before, right? It's just above the container. And we'll do this. We'll just say navbar. Okay, and then actually we want to do that. Okay, so that would render it out, but if we do that, we'll notice that, it doesn't know what this.state.account is, all right? It's gonna break it. So the state object from this component is not accessible inside of this component, all right? So we have to pass down that value some other way. So we do that like this. We say account, all right? We can just tell this component what the account's gonna be. And we can say this.state.account, right? Which is what we used originally. And that'll pass this account variable down here. So we read that account variable inside this component, not with this.state.account, but with this.props.account, all right? So props is just a shortcut for, or shorthand for the component properties. And that's the same thing we saw here inside the constructor, props, right? Component properties. So these are just variable values, right? So, and these are props right here. Like that's what this looks like. Okay. All right, so let's save that, go back to the page, and there we go. Boom. We've got the address. So that's going to be like our username on the blockchain. So the next thing I want to do is use a cool avatar for the blockchain users. All right, this is something new for this tutorial. If you guys have seen my other tutorials before, this is going to be a new trick just for you all. Okay, so what I want to do is use something called identicons. So identicons are going to be a way that we can actually generate cool, avatars for the users based on their Ethereum address. Okay, what it does is it gives you a function that will generate a new identicon from some sort of data, right? And this data will spit out, a cool image like this. And in this case, we can just use a unique image for each Ethereum address that we create. All right, that's going to be our avatar on the blockchain. So I'm going to install it in the project because we haven't installed it yet. Normally, you would just do npm install identicon.js -- save, but I'm going to specify the version. So I'm going to go to the package.json file. And let's see here, I'm going to say, paste this in. So you want to get this from my project. This is identicon.js version 2.3.3, right? So I'm going to save that. In order to reinstall this, we need to stop the server and say npm install. All right, it worked. So again, we got some warnings and some errors here, but it actually added the package. I realize these aren't ideal, guys. Sorry about that, but it's working. All right, so we'll start the server again with npm run start. All right, let's go back to our page, make sure everything is still working after installing the packages. Yep, all good. Okay, so now let's add the identicon for the user in the navbar. So we'll just import the newly created library, or the newly added library, I should say. All right. So after React, we'll import identicon. All right, just like this, and we'll add the image to the account like this. So identicon tells us that we need to do it like this. Let's see here. We give it an image with a width and a height, and we use data as a source, and we concatenate the string. So I'm not going to do it like this. This is kind of a crazy way of doing it. That won't work for our React project. I'll show you how to do it custom for our purpose. All right, so let's see here. Say image, and then we're going to say class name. We'll say ML2. That's just a bootstrap utility. Say width. Let's do 30, and then height equals 30. And then, sorry, I'll pull this up. We'll say source. All right, so we want to do what identicon told us to do, and use this. All right, that's the basic source that it tells us to use, but we actually want to pass the data in after that. So see source, data, image, yada, yada, yada. This is telling you to add strings together. We're using ES6 so we can actually interpolate. That's what these little backticks do. All right. So I'm just going to use $ and execute JavaScript inside of here. And this is this is probably not the best way of doing this, but I'm going to do it all in line just so that you see how it works. So I say new identicon, and then say this .props .account. All right, and then they tell us to give us a size. So this is 420. We're using 30. All right, so 30, and then say to string. All right, so that's kind of funny looking, and we also need to give our image a closing tag. Let's see here. All right, I'm gonna give this a new line. All right. That's kind of crazy looking, but it's just easier to read. I could put this inside of a new function or something like that. Certainly refactor this to make it look better, but that's the gist of how this works, okay? We're just creating a new image with a source, and we create a new identicon with the Ethereum address that we're passing in with this .props.account. Okay, so lastly, we only want to do this if an account actually exists, or else it'll break. So we'll say this.props.account. So if it exists, basically what we're going to do is use a ternary operator, which is just saying if this is true, then do this. If not, then do something else. That's really pseudocode, but you get the idea. So if it does exist, we want to render out the image. All right, so we'll copy this. All right, and we'll format it. And if not, we just want to, we'll just give it an empty span tag. All right. There's probably a better way of doing that, but that's the idea. Okay, so we'll save that, go back to the page and see if it worked. Boom, there we go. Awesome. So we can see our fancy new avatar here on the blockchain. This is going to be our avatar for this particular user that we're logged in with. All right, so that's it for this section, guys. You've connected your app to the blockchain. You now have a blockchain-based application. You've connected with MetaMask. You've got your accounts imported. We can see our account on the page, and you have a cool new avatar that represents your user on the blockchain. So I hope you all like this video. I hope that's a cool new trick to any of you who've been watching this channel for a while. I think you'll like this. In the next video, we're going to go ahead and start creating posts so we can list them out on the page, and then we'll continue on tipping and stuff like that and build out the full social network in the next video. So welcome back. We're going to continue building out the client-side application in this tutorial. In the last one, we wired up this application to the blockchain with Web3.js. We imported our accounts into MetaMask, and we listed out our account on the page right here with this cool new Identicon avatar that's generated based on the Ethereum address. All right. So what we want to do now is continue building out the social network. We want to show all the posts on the page. We want to create new posts, and we want to be able to add tips to posts. All right. So there's a little bit of groundwork to do. First, let's go ahead and create a post so we can list it out on the page on the social network. I'm going to go to my terminal, open the Truffle console. As always, make sure you have Ganache running, the blockchain, and make sure you've migrated your smart contracts to the network before doing this. All right, so I'm going to get the social network contract. We'll say network. I'll say social network equals await social network dot deployed. All right, social network. All right, there it is. I'll say social network create post. Say await. I'll say this is my first post. All right. Boom. There we go. So we have a post. Now let's go try to list this post out on the page for the project. Okay. So we need to actually import our smart contract into this app when we do that. Okay. So let's see here. We want to fetch it from this file. All right. So inside the source directory, we see source ABIs, and we have the social network.json file here. All right. So let's do that. We'll import it just like this. Go just below app.css, import, boom. So we'll import social network, right? Capital S, capital N, from this file right here. So dot means go upper directory, enter the ABIs folder, and then use the social.network JSON file. Okay. All right. So now that we have that, we can talk to the smart contract. And we're going to use Web3.js to get an instance of the smart contract in JavaScript inside this app. So when we do that, we're going to use this web3.eth contract. Okay. So this is an example. Basically, we'll just do this. All right. And then it needs two pieces of information. All right. It needs the JSON interface, which is the API, and the address. So we have both of those pieces of information inside that file. All right. Go to social.network.json. Here's the API, right? And then the address is, you'll see here. Yeah, address is here. Boom. So you'll notice that the address is nested way down in this file under this networks key. All right. So there's multiple networks this could potentially be deployed to. So it could be deployed to Ganache, could be to a test network, it could be to the actual main Ethereum network. But in this case, we just want to find this address. So we need to open this file, figure out what network we're on, and then find the address. And once we have those two pieces of information, we'll be able to do this and create an instance of the smart contract that we can use in JavaScript. All right. So let's do that. Go to app.js, and inside load blockchain data, we've already loaded the account. Now what we want to do is we need three pieces of information. We need the address. We need the ABI. All right. But in order to get the address, we also need the network ID. Right? Because inside this file, this is the network ID. So we can find the actual address. All right. So we can get the network ID with Web3 like this, a const network ID equals await web3.eth.net get ID. All right. And I'll console log that. Go back to terminal, or sorry, the browser. And there we go, 5777. All right, that's right. We need to find that information to go here. All right. And then now what we want to do is fetch the data, the network data, right? This is the network data right here, networks 5777. So we can do that like this. We say social network dot networks, right? That's just the key. and then pass a network ID. All right. So that's going to be, this information right here. So that's going to tell us what the actual address is. So essentially, like, if that information exists, we want to instantiate the smart contract with Web3.js. And if it doesn't, we'll just say that the social network contract has not been deployed to the blockchain. All right. So we'll just run this again. We'll say console.log network ID. I'll show you what that looks like. All right, so here it is. But if we change networks and go to the main network maybe, right? Say mainnet. Refresh the page, then boom, it'll break, right? Social network contract not deployed to detected network. That makes sense because we haven't put it on the mainnet. We've only put it on Ganache, okay? So we'll go back to Ganache. Oops, sorry. Refresh the page, and it still works. All right. So basically, if the smart contract is detected, we're going to do some more stuff. We're going to take all the info that we have and create an instance of it like this. All right. So inside of here, we'll say this. We'll say const social network. Oops, lowercase social network equals Web3 ETH contract. We'll say capital social network dot ABI. All right, that's the ABI, and then network data address. Okay, so that should give us everything that we need in order to create the smart contract. So console log social network. Oops, got a problem here. Network data is not defined. Let's see here. Let's call this network data. All right. Boom, there we go. Here's the smart contract. Awesome. So this is everything that we need in order to call methods on it. We'll be able to do things like call the Solidity functions that we coded previously, right? We'll be able to say, you know, like, let's see here. We'll be able to call create posts. We'll be able to call tip posts with Web3.js, right? I'll show you that here. We'll be able to use this syntax with Web3.js, right? You see my contract, methods, my method. So this could be any method that we created, like, let's see, you know, create post, my contract, my methods create posts, right? And then pass in all the parameters. Just like we did in our test, but it'd be slightly different because we're using Web3.js directly, okay? So let's see here. Let's go ahead and do that. Let's say, let's get the post count because we want to do that in order to list out all the posts on the page. It should be 1 in this case. But before we do that, let's go ahead and say this.set state. Let's see here, social network. And we want to save a copy of this on the React state object so that we can use this smart contract later, okay? So we'll update this as well. Social network equals, so the default value here can just be, well, let's just, we'll not even put it here. It'll just be null. Oops, sorry. All right. So also really quickly, this is just a shortcut inside ES6 for this. Right. If you have a key and a value that are the same name inside of an object, you can just do that for shortcut. Okay. So this is this.set state. We're going to store the social network contract for later. Next, let's actually get the post count. So say const post count equals await social network dot methods. All right. So go back here, dot methods, and we'll say post count, and then that's not actually going to call the method. That's just going to return it. Okay. If we want to actually call it, we say dot call. Okay. And then we can just say this dot set state post count. And then initially we'll just say post count is going to be 0. All right. You can also console log it. Save it. Go back to the terminal. refresh, and there we go, boom. So it's a big number, which is okay. That's what we expect. But we got the value back. All right. Let me explain another thing really quickly. Inside Web3, there are call methods and there are send methods. All right. You can see this right here. We have to do my contract, methods, my method, call. All right. And then you can do send on other methods. So call methods are essentially functions that just read information from the blockchain. They don't cost any gas, all right? But send methods write data to the blockchain, and they do cost gas, and you have to sign these transactions with your account. We'll see that later, but I want to go ahead and make that distinction right now. There's call functions, and then there's send functions, okay? That's all we had to do, .call here. All right, so now we've got the post count. So we need the post count in order to understand how many posts we have before we list them out on the page, all right? Remember earlier when we built this social network smart contract, I mentioned that you can't just get all the posts by saying, social network posts, call the function, and then get them all back, right? You actually have to pass in a key, which is going to correspond to this key right here, the ID. And you have to read them out individually, one by one. So you call posts, pass in 1. That's going to give you back this post with ID of 1. Say post.2. It's going to return post number 2. Okay. And we can, loop through those in JavaScript with a for loop and just fetch each one out individually because we know how many posts there are with this post counter cache. All right. So we'll do it just like this. We'll say load posts. All right. And we'll say for var I equals 1. I is less than or equal to post count. All right, and then I plus plus. Okay, this is just a for loop that's gonna loop over every single number from 1 all the way up to the complete number of posts that we have. In this case, we just have 1, so it's just gonna run 1 time. But if we had 10 posts, it would run 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 until it's less than or equal to this, right? Or until it's equal to this. All right, so inside of here, let's just fetch the post out. We'll say const post equals await social network dot methods posts, pass in the ID, which in this case is going to be 1. Say call. All right, it's going to fetch the post out from the blockchain. It's just calling this function right here. All right, posts, right? And then we're going to store it inside the state. So we'll say this.set state. All right, and we're going to write the posts. So initially we want posts just to be an empty array. Posts equals empty array, just like this. All right. All right, this.set state, posts. And instead of just, updating that actual array, right, we want to use the ES6 spread operator, which looks like this, this.state.posts, say posts. All right. So essentially this just creates a new array, right? And it uses the old posts and adds the new post to the end of that array. All right. So that might look a little confusing, but just trust me, that's how you kind of do it with ES6 and React. All right. So after this, let's just say console.log, and we'll say posts, right? Whoops. So we'll say posts is equal to this.state.posts. All right. There we go. Boom. So there's all the posts. There we go. Awesome. We can see data coming back from the blockchain in our browser. We did it correctly. Yay. All right. So here's the ID. This is my first post. And we can see the author. We can see the tip amount. Boom. Perfect. So now we're cooking with fire. Let's go ahead and try to list out some of this information on the page while we're here. All right. So let's do it like this. Let's take let's just use a loop and put them out on the page down here. So I'm going to use a Bootstrap card in order to model these posts. All right. This is what this looks like inside Bootstrap. We can basically just create a card with a header and a body, and it can support a button. All right. So I'm going to take something like this and kind of modify it for the post that we're going to show on the page. So I'm going to go back to the application and find all this content inside of here and go ahead and remove it. Okay. So essentially, I'm going to go back to this page, find the main component, or sorry, the main element, find this div class name, and then take out all this stuff, right? So you should have this left. All right, we're going to put new content inside of here. So what I'm going to do is loop through each post and render out one of these bootstrap cards that I showed you right here on the page, right? So at this point, this should be empty, but I'm going to put one of these on here for each post. So we can loop through all the posts like this. Boom. All right. Say this.state.posts, all right, then map over it. And then we're going to have two values, the post and then the key. So the key is essentially going to be the index, and that's what we need in order to tell React that each element that it renders out to the page is unique, all right? So we want to use a return here. And I'm just going to go ahead and paste in the basic content for the card. It's going to be the bootstrap content, all right? Say boom. All right, done. So essentially, this is just going to be a boilerplate card, right? It's going to have a header, and it's going to have a body, right? We'll change this in a minute, and it's going to have a footer, okay? And also, while we're here, I'm going to change some CSS bootstrap utilities. So instead of using, let's see here, deflex and text center, we're going to use, let's see here, ML auto and MR auto. And then we'll say also style equals max width 500 pixels. All right, so let's go to the page and see what that looks like. Oh, there we go. So that's what our basic post is going to look like. It's going to have a header, it's going to have a body, and a footer. So we can go and fill out these items. The header is just going to be the post author, so I'll fill that in like this. Say post author. All right, the body is going to be the post content. Post content. All right, bump this back up. And then the footer is going to be tips. So say to do tips. Well, I guess we can go ahead and fill in. We can go ahead and fill in the tips. We just won't wire it up yet. Boom. We can add tips like this. All right. So this will just be a list item that will have the number of tips and then a button to create the tip. All right. So these don't work yet. They're not wired up, but we'll just take a look and see what we have. Boom. There we go. There's our first post. So there's the author. There's the post content. There's a number of tips and a button to tip, which is not going to do anything yet. So let's make some changes. We're making good progress. Let's actually list out the number of tips on the post. So we'll do that like this. We'll say tips. Instead of just telling it it's got one, let's actually read the number. We can say window.web3.utils. This should look pretty familiar because we did this in the test in the previous videos. So from way, and we'll say post.tip amount to string, and we'll say ether. All right. Boom. So 0. That's what we expect. All right. And then this is the button we'll use later to actually tip the posts, but it's not going to work yet until we get there. Okay. All right. So lastly, we want to show the identicon for the author. All right. We're going to use an image just like we did in the nav bar. So I'll just copy this image and then go back into the post, and I'll paste it just before the author. All right. So let's see here, author. Paste this in. All right. It's kind of messy. Sorry, guys, but you get the idea. All right. Pull this back. All right. We'll go over one more. So instead of margin left 2, we're going to say margin right 2. And then we also want to import identicon at the top. So we'll go back to navbar, import identicon. Let's do it here. And we can go ahead and remove the logo. We don't need it anymore. All right. And let's, problem. A hash of at least 15 characters is required. That's a few problems here. This should be state All right, but sometimes the account's going to be not what we expect, but let's just give it a try. All right, so it still works. Awesome. All right, so there we go. There is our skeleton for our posts. And as we add more posts inside of here, it's going to create more cards below this, and we'll see a huge list of them. And then above this, we're going to create a form to create new posts, and then we'll be able to tip them eventually. So let's go ahead and move on to that next section. That's where I'm going to show you how to create new ones. All right, so I'll catch you in that next video. All right, in this section of the tutorial, we're going to continue on building out the client-side application for this social network that's running on the blockchain. All right. So in the last video, we listed out the posts on the page. We just have one post so far. So in this video, we're going to create a new form that's going to allow us to submit posts to the smart contract. We're actually going to be able to sign the transaction with MetaMask and put the post on the blockchain. So really quickly before we start, I made a mistake in the last video that I want to correct. Whenever I show this Identicon avatar, I did it for the current account, and it really should be for the author of this post, which is different, you can see. All right, so let's fix that. So instead of this.state.account, this should be post.author. All right, so that's my fault. Sorry, guys. So save that, go back to the page, and boom, there we go. We should see a different Identicon. This is the one for the person who actually created the post. All right, so here's here's the account we're logged in with, and here's the author of the post. It's two different people. All right, awesome, cool. So now that that's fixed, let's move on and create a form. So in order to do that, I'm going to go ahead and create a new component, just like we did for our navbar. So we put the navbar information inside of its own component. We're going to put all the content for the page also inside of its own component. So it's a little bit of refactoring here. I'm going to take this navbar and do this, create a new file, and say main.js. I'm just going to paste the navbar code and take out all the HTML, all right? And change navbar to main, all right? So that's going to be our boilerplate for the main code. So I'll take all of the HTML that we wrote in the last section. Let's see, sorry, from app.js, and I'm going to minimize it. I'm going to copy it, or cut it actually, and paste it here. And boom. Just put everything inside the return statement. All right, and that should be all we need to do, except for changing a few things. Let's see here. So anything that says this.state, well, let's change that in a second. All right, let's import the main component. Go back to app.js. All right, right below navbar, we'll just copy this, paste it, change it to main. All right, and right below navbar, we'll copy this and say main. And we don't necessarily need the account, but we do need the posts. All right, so we'll say posts, this.state.posts. And because we're converting this to props, we need to reference these with props inside the component. So go back to main.js and find anything that says this.state, right? This.state.posts, just one thing, and change it to props. This.props.posts, all right? Save that, go back to the page, and it still works. Awesome, very cool. So it's going to be apparent why we did this momentarily, all right? Basically, whenever we submit our form, we're going to have to show that the field is loading. So let's go ahead and do that. I'm going to create a loading state for the application. All right. So essentially what I want to do is show that the app is loading if we're waiting on the blockchain for information. And if not, we're going to show the content. All right. So what I can do is say, let's see, so we could change our state, say loading. We can say true. All right. And what I'm going to do is say here, I'm going to use some JavaScript and say this.state.loading. Say question mark. If it's true, we're going to do one thing, and if not, we're going to do another. Say div ID equals loader. Say class name equals text. Oh, sorry, text center. loading. All right. And if not, then we're going to render out this main. All right. So right now I've hard-coded loading to true. All right. And when it's true, we're going to show the loader. But when it's false, we're going to show the content. All right. So let's do that. And it looks like we can't see it, so I'm going to say MT5. All right, perfect. There we go. I just added some margin. So whenever the app's loading, we're going to show this, and when it's not, we're going to show the content. Okay. So I can say, loading false. All right, whenever it's done, it's going to show the page. So we're essentially going to, set the state to loading whenever we're, fetching information from the blockchain. So I'll show you what I mean by that. We're going to set this to true by default. All right. But whenever we actually are fetching information from the blockchain, we're going to, update that it finished. And simultaneously, we're going to, and likewise, we're going to, tell the page that it's loading whenever we submit new information to the blockchain. All right. So this does set state. All right. Posts. And then we're going to say, this set state loading false. All right, so we should see a little flash here. All right, boom, you see that? So whenever we're talking to blockchain, it's going to say loading, and when it's done, it's going to show the content on the page. All right. So that's going to be helpful for us whenever we decide to create a form. All right. I'm going to go back inside of our main component, and just above this section where we list out all the posts, I'm going to paste in a basic form here. All right, boom, done. All right, so essentially this is just an HTML form that has an input inside of it that's going to be the content of the post. We'll have a placeholder and then a button that will submit it. All right, so let's save that, go back to the page, and there we go. You can see that we can do that right here. So I'm using this for spaces. Probably not the best way to do this, but it works. So save it and go back, and boom, there we go, 2 spaces. All right, what's on your mind? We'll just say this is my second post. All right, but it won't do anything yet. All right, that's because we haven't wired it up to go to the blockchain yet. All right, so let's go ahead and do that. Let's fill this out, click share, and we should be able to sign this transact with MetaMask and put it on the network. So we need to call the smart contract function for this. This is, let's see here, it's a source, contracts, social network. We want to call the create post function. So how do we do that? Well, we could do it with the Web3.js smart contract that we instantiated here. All right, we can go back to our documentation and see, my methods. We want to do send. All right, because this actually creates a transaction and puts it on the blockchain. So my contract methods create post, we'll pass in the content, and then we'll pass in some options, which is going to be the account that's going to do it. All right. So we'll create a new function just for this. All right, we'll go back to our app.js component, and we'll do this. We'll say just below load blockchain data above constructor. We'll say create post. All right, this will be the name, or content, sorry. And here we're going to basically get the social network. So this.state.social network. All right, it's here. And we're going to say methods and say create post and pass in the content. All right. So remember, this doesn't call the function. We have to actually call send, like this. Send. And I'm going to pass in the account who's actually going to create this transaction. In this case, we want to use our MetaMask account. So this will be from this.state.account. Okay. That's who's going to actually create the post, sign the transaction, and put it on the blockchain. All right. So we can see from the documentation that you could do that like this. You can pass in a callback function, or you can do then, right? Or you can say on or once, okay? And after it's finished, once it's actually submitted, we want to tell the loading is false. So we'll say this.set state loading true. And then we'll say wants receipt. We'll say receipt. This.set state. Loading false. All right, so that's how we create the post. Now we want to call this function inside the form. So in order to do that, we have to access this function from this component right here. So how do we do that? Well, I need to pass it down. So here, main, let's say posts. And then, let's see, create post. We want to say this dot, let's see here, this dot create post. Tell you what, let's put it below the posts. All right. But in order to access that, we need to bind it to this. So we'll say, just like this. We'll go inside the constructor and say, boom, this dot create post, bind this. All right. Awesome. So let's go back to our browser, make sure we don't have any big errors. Nothing, it's got some warnings. This is basically just like HTML stuff, no big deal. All right, so I'll go back to main.js, and we're gonna actually call the create post function whenever we submit the form. So we're gonna use an onSubmit handler to do this. So essentially, you can listen to events inside of React like this, say onSubmit. So the submit event will be triggered whenever the form is submitted. We'll pass in a function. This will be the event. All right. And inside of here, we'll say event prevent default. That'll keep it from reloading the page. And then inside of here, we can call this.create post. All right, then pass in the content. But what's the content? All right, how do we get that? Well, React has something called refs, which will allow us to get the content from this input. So I'm gonna do that like this. I'll say, boom. All right, ref equals input. So this dot post content, right? It equals the input of this here. So I can say const content equals this dot post content dot value. That'll read it from refs. All right, so content, boom, done. Awesome. All right, so I think that's everything that we need in order to put this post on the blockchain. Let's give it a try. Refresh the page. So empty handler on submit. Be ignored. All right, I see the problem, guys. I made two typos here. So this is not spelled correctly. Set state, also set state. Okay, so I'll save that, go back to the page, try this again. This is my second post. Click share. All right, so a MetaMask confirmation popped up off my screen, which I can see here. I'll click confirm. All right, and let's see if it works. All right, boom, it's done. And we can see our second post. All right, there we go. We can see I have two different posts from two different authors, and this is the same avatar, and the address is the one that we're connected with, okay? So we've successfully been able to create posts. I'll put my third post in. This is my third post, click share. See MetaMask confirmation pop up again, click confirm, and boom, awesome. We've got 3 total posts. Very cool. All right, so that's it for this section. We've been able to successfully create posts. In the next video, we're going to update posts by tipping them, all right? We're gonna wire this button up so that anybody can come in and tip the posts, and we're going to sort the posts to where the highest tipped posts appear at the top, all right? And that's gonna make our social network, kind of rewards based, all right? So I'll catch you in that next video. All right, so now we're in the last section. In this part, we've been building out this client-side application for our blockchain social network. And, we've created posts, we've listed out all the posts, we show the authors with these cool identicons, these avatars. And in this section, we're going to actually allow people to tip the posts so that, they can reward the authors. And we'll just allow them to tip, 0.1 Ether. And we're going to wire this up so the button can do it. They're going to send some cryptocurrency to the author. And we're also going to sort these posts so that the most tipped post appears at the top. All right. So we'll go back to our code. We'll go to the main component, and we're going to create a new button here. All right. So if you go into main, this span that says tip, 0.1 ETH, we're actually going to wire this button up to, do that. So just like the form, in the last section, we used an onSubmit handler. Right here, onSubmit. In this case, we're going to use an onClick handler. So whenever the button gets clicked, we'll call this function. So we can just say like onClick equals some JavaScript, say event. Okay. And then inside of here, we want to call the tip function. Okay. So we don't have it yet, right? Remember, we called it inside of here with a form submission, but we haven't, we haven't actually done it yet. So let's go back to the app.js file, and just like create post, we'll say tip post, say tip post, and in this case, we want to know the ID of the post that we're going to tip. Right? Let's say ID, and we'll say tip amount. Okay, and just like the previous function, we'll say this.set state. Loading, true. All right, and then when it's done, we'll stop loading. But we'll call the function just like we did here, this.state social network tip post. All right, and we're going to pass in the ID because that's how the function works on the blockchain. Right, we can just see that here. Tip post ID. Right. And now we need to pass it the actual tip amount. Okay, so we're going to do this a lot like we did on the tests, but we're going to use this send method. And so I say send from this.state.account, and we also need to pass in the value, which is the tip amount. All right, so value tip amount. Right, remember this is the function metadata that specifies how much cryptocurrency is going in. This is going to be some Ethereum cryptocurrency, and the value is actually going to be expressed in way like we did in the tests. All right. So after that's done, we'll say once receipt, pass in the function, this to set state, loading, false. Awesome. A little more work to do. We'll go to the constructor function and say, this.tip post. We'll bind this. All right, and then likewise, we'll say tip post equals this.tip post. Awesome. Now we should have access to this value down inside this main component. All right. So let's see here. Now we want to use the tip post function inside this onClick handler. So we'll say we need to actually get the tip amount first. So, and we also need we need the ID of the post. So we need a few pieces of information inside of here. We need the tip post function. We need the ID of the post. And we also need tip amount. Okay. So the post ID, we're going to just pull it off the button. So in this case, we'll just say name equals post ID. Okay. And we can pull that off here. So the post ID will be, let's see here, event.target.name. That'll be the ID. And the tip amount, let's always tip, just like we said here, 0.1 Ether. So that's what the tip amount will be. So say let tip amount equals window web3.utils two-way 0.1 and then say Ether. All right. So then the actual function call will be this.props.tip post, and then we'll pass in the ID. All right. And then we'll pass in the tip amount. And that should work. So there's the function, there's a tip amount, and that should work. All right, let's try it. Let's go back to the page, refresh. Let's see if we can actually tip a post. Let's make the third post the highest. So click that. Oops. This state social network tip post is not a function. So it looks like I had an error here, guys. My fault. So we'll go back here and go to app.js. .methods.tip post. My fault, guys. Refresh the page. Let's try it again. So tip the bottom one. All right, let's look at another issue. All right, so I think that's what the issue is. So if we go back here, I think, it's reading the ID from the target. I think that it believes the target is the span. So we want the target to be the button. So let's take that out. Remove this span here. We don't need it anyway. Just save it. Go back to page. All right, it still looks the same. So also while I'm here, let's go ahead and change to the tipper account. All right. So go to tipper. All right. Tipper had this. All right, so let's try to tip the post. This. All right, now I got a MetaMask confirmation popping up. That's what we want. So let's click confirm. All right, there we go. Awesome. Boom, it worked. So we can see the tips here at the bottom. So 0.1 Ether on this post, none on this one, and none on this one. So I'll tell you what I just did. You saw that transaction error happen. Sometimes MetaMask caches your account data, and you need to go into settings. Let's see here, settings, and just reset the account. Let's see, advanced, reset. All right, this is safe to do. This is not going to lose any data on the blockchain. It just resets the data inside of MetaMask. You'll lose your transaction history, like this receipt log here, but that's just inside the app. It doesn't affect anything on the blockchain. So that fixed it. All right, awesome. So this is the post. So let's tip it again. Let's tip another one. Tip this. Let's kind of have an array of tips. Confirm. All right, so this one has 0.1 ETH now too. And let's tip this one a little bit more. Click confirm. Awesome. So now we have 3 different posts with tips. This one has the most, this one has the middle, and this one has the least, or no tips at all. So what I want to do now is actually sort these to where the highest tipped post appears first in the list, and the lowest tipped post appears at the bottom. All right, that's going to make our social network basically, show more quality content at the top. All right. So let's see here. Let's go back to app.js, and we're going to sort the posts after we read them out of the blockchain. All right, so we'll just say we've loaded the posts here. Now let's sort the posts. We'll say sort posts, show highest tipped posts first. Say this.set state. Posts, this.state posts, say sort, and then we're going to do A, and then B. This is how you sort. And then what we're going to do is say we want the highest tipped first, so we'll say B.tip amount minus A.tip amount. All right, so save that. And then that should update it. So we take the current posts, we sort them, we reset it back to the original. All right, so save that. Let's go back to the page and see if it worked. Okay, so one little problem here. Oh, and I don't even need these curly braces here, right? Sorry, if I did, I would have to do a return, but I'm not going to. So I'm just going to do it's a single arrow function by itself, just a one-liner. Save that, go back here, all right? And there we go. We can see the posts are sorted like we want them to. The most tipped post is at the top, and the least tipped post at the bottom, and the middle one's in the middle. Awesome. So there you go, guys. You have a complete decentralized social network backed on the blockchain, powered by smart contracts, with a website that can use it. You can create posts, you can sign transactions and put them on the blockchain, you can tip the post with cryptocurrency, and the most tipped posts appear at the top, so we can actually curate, crowdsource better posts by people paying to see better posts at the top of the newsfeed. So congratulations. Now you've come a really long way from absolute beginner knowing nothing about blockchain all the way to building something like this. So pat yourself on the back, all right? So I hope you really liked this tutorial. Again, check out the code, check out the article on my website. And if you're serious about becoming a blockchain developer, you need to join my free training on my website over at dappuniversity.com/bootcamp. All right, until next time, thanks for watching Dapp University.